So generally the level 2 person is the one who is responsible for ensuring that we get ground covers and or vegetation established on areas in which there is no additional grading or there's a temporary stop in grading. So in terms of how we get this vegetation established, first of all, we know that it's a very good erosion control practice. So that's why most of the non-paved areas around DOT projects will be grassed in order to stabilize and prevent erosion. So the long-term solution is usually a permanent stand of grass or other vegetation. And there can be other types of stabilization such as rock and concrete, but most areas are going to be grassed because that's the least expensive and it's very effective. We are required by law to cover up slopes that are left exposed during the grading operation. And this has to be done within 7 to 14 days. So for many, many years, we've had to have a ground cover. And as I said, it could be grass, it could be plastic, it could be rock, it could be any numbers of things, just as long as you're restraining erosion. And then in 2019, we had part of our general permit indicate that we need to have this established within 7 to 14 days. So when is it 7 and when is it 14? Well, the high risk areas such as dikes and swales where there's water flowing or the perimeter of the project, those are all going to need to be established within 7 days after the grading is finished on those particular practices. Also, if your project is, or some part of your project is within a high quality zone, then those waters need to be protected, and we're going to have 7-day requirement. And that will be on your plans. So whoever made up your plans is going to know what part of or what whole project is within a high quality water zone, such as a lake or a trout stream. In addition, if we have steep slopes, steeper than 3 to 1, it's going to be a 7-day requirement because those can have a lot of erosion. Unless they're short, like only 10 feet or less, and then you can go with the 14 days. Slopes with 3 to 1 or less slope, those are 14 days unless they're very long, like 50 feet or more, because that can generate a lot of sediment. So those will be 7 days. And everything else is 14 days. So now you know, 7 or 14, those are the 2 time frames. So how do we get vegetation established? Well, we have to physically prepare the soil. We have to have certain amendments to the soil or pre-ground cover applications, and then we're going to need some ground cover. So let's go through these steps. First of all, in order to get the soil prepared, we want to smooth out the uneven areas, loosen the soil in some way. So this tractor is dragging a piece of equipment that will loosen up that soil. That allows the seed to germinate and penetrate into the soil. And then we want to track. And this is an important process to establish little furrows and ridges, and this will keep erosion from happening by stopping the water from flowing directly down the slope. As you can see, as you track up and down the slope, you leave these little micro ridges, and that keeps the water from flowing too quickly down the slope. So it's very effective. The seed generally will settle down into those little valleys and establish themselves, and will get a good stand. Make sure that you track up and down the slope and not across the slope. When you track across the slope, you end up with rills that follow those tracks, and you've actually accelerated erosion instead of slowing it. Now, we need to amend most soils in North Carolina with lime and fertilizer, and then we add the seed and the ground cover. So let's talk about the lime and the fertilizer. Why do we lime in North Carolina? Well, most of our soils are acidic, meaning they have a pH of 5 or even lower. And in that case, plants just cannot grow, especially grasses. So we add lime and that brings up the pH, and we no longer have the toxicity of the aluminum in the soil, and the plants are able to grow. We go with this blanket application of 2 tons or 4,000 pounds per acre. Now, there may be areas that need more, some that need less, but this will generally get the pH up to a point where the grass can grow. Whether you use powdered or pelleted, doesn't matter. Powdered is better in terms of reaction in the soil, but pelleted is okay as well. Most of our soils are going to need additional fertilizer, so plants can grow with nitrogen, phosphorus, and potassium. You can see the bag on the example of the bag on the right. It's got the guaranteed analysis, and every bag of fertilizer has to have that. It will tell you how much of the different types of nutrients are there, but we're mostly focused on the nitrogen, phosphorus, and potassium. We want to have at least 10% nitrogen, 20% phosphorus, and 20% potassium. So that's where the 10, 20, 20 comes from. This particular blend is unusual, but it's helpful in establishing grass without having a rapid growth that you might want, say, in a lawn or on a golf course. So it helps the grass become established, but it doesn't need to be growing really fast and with a deep dark green. So how much do we apply? We're going to go with 500 pounds per acre. So relatively low rate compared to lawn or other applications, but it's enough to get the grass established, and that's all we need is to get the grass established so it prevents erosion. Now, if you happen to be in the Jordan Lake watershed, there's additional training required if you're a commercial operator. So if you're being paid to apply fertilizer, usually seeding companies, you must have this additional training. So what's the Jordan Lake watershed? Well, it's mostly Guilford and Alamance County plus parts of Orange, Durham, and Chatham, and a little bit of Wake. So that's Greensboro, Burlington, Durham, and all parts in between. Here's a map that shows you approximately where that watershed is. So again, if you're a commercial operator applying fertilizer in this area, you have to go through additional training and get a certificate. So the training is available online at this website, the second bullet, and has modules for agricultural, urban, or both types. And once you've reviewed all those, you can contact the Department of Environmental Quality person. Currently, it's Patrick Beggs at this email address, and that's on that page as well. And once you've told them that you have viewed these slides, then you can get a certificate. All right, so we talked about fixing the soil physically and then chemically with lime and fertilizer. So now it's time to put out the seed. Now, the type of seed that you apply depends on where you are in the state, the time of year, what kind of a slope or area it is, and whether this is a temporary or permanent seeding. So we're going to go through all these different options for seeding. So in terms of where you are in the state, we have cool season grasses, which are going to be applied in the dark green area. So all the counties basically west of Wake and Raleigh. And in the eastern part of the state, we're going to go with a warm season grass, and that's centipede or Bermuda grass. The difference between the two is the warm season grasses green up in the summer and then go dormant or turn brown in the winter. They're not dead, but they go dormant. While the cool season grasses, fescues and bluegrass, those will stay green year round and grow primarily in the cooler parts of the year. So here we're going to go through some scenarios to give you an idea of how we would pick seeds. For example, Division 2, which is down east, and we finished our grading and it's April, time to put out some seed. We would put out 50 pounds of tall fescue. That's going to be sort of a nurse crop. We'd also then put out centipede and 25 pounds of Bermuda grass. Those are the warm season grasses that are going to be permanent. So notice how we've said here a hulled Bermuda grass. So the seed naturally of Bermuda grass has a hard outer casing that helps it survive over the winter. However, if you apply it with a casing in the spring, that'll delay its germination. So in the warm parts of the year, we use whole Bermuda grass. All right, and as I mentioned, the fescue, we already talked about how that's a cool season grass. It will grow in eastern North Carolina, but it's probably going to die out and the area will be taken over by Bermuda grass. Same area, we've had a delay. We're not finished grading until December now. So we're going to still use the fescue and the centipede and the Bermuda grass. However, we're going to use unhulled Bermuda grass. So this is, the seed has not had the outer casing removed because we need that seed to survive the whole winter. So it's a little bit different mix, 35 pounds instead of 25, because we're probably going to lose some of that seed over the course of the winter. All right, so here's a quiz. What types of temporary seed species are used in the East? Well, we actually don't use temporary seed. We mentioned that we have the fescue as a nurse crop, but it's not temporary. It'll stay. It may stay on for a long time. Now, the western cool season areas, we do have a temporary seed mix that we use. So speaking of the West, here we are in Division 10. So in the Upper Piedmont, and it's March. We're at final grade on the shoulders and medians. So this is our standard mixes. We're going to use a mix of hard fescue, Kentucky bluegrass. Those will be our permanent species. And then this is our temporary species, the rye grain. Rye grain will grow very quickly and protect the site while the other two are getting started. So what if we're in a waste and borrow area? So we know that waste and borrow areas are off the project. They're where we've gotten soil or we've gotten rid of soil. They're on private property that we need to be sure is stabilized. So we're going to use a higher rate of seeding, as you see. We're going to use some tall fescue, hard fescue, Kentucky bluegrass, and again that rye grain as a temporary species to kind of get the others started and protect the site. So if you haven't seen the rye grain, you can see it right here. Very tall, it grows quickly, forms a seed head, but then it dies out and the seed never germinates. So it's a great nurse crop for the other species. Now, if we're in areas that are usually near wetlands or other bodies of water, we're going to go back with native seeding. And the reason we use native grasses is because this area has a lot more wildlife than we expect on other areas. So 50 feet on each side of streams and wetlands, we're probably going to be putting out native grass seedings. So down east, that would be Bermuda with Indian grass, little blue stem, switchgrass, and millet. And in the cool season areas, we'd be using the Kentucky bluegrass with big blue stem, etc. So different seed mixes. These are very expensive. They're slow to establish, but we want to plant natives where we expect to see a lot of wildlife. All right, so what are some of the problems we run into when we are trying to get vegetation established? One is inadequate cover, not enough of the cover material, whatever it is. And so, for instance, straw. Didn't put enough straw out to protect the seeds. Poor seedbed preparation, that is compacted soil that has not been roughed up and scarified, or not enough amendments, didn't put enough of that lime or fertilizer out to correct the pH and get the fertility up. Or you may have seed that's dead, essentially. It's expired. So every bag of seed is going to have a tag on it with a date, and that will be given to the inspector to ensure that you're using the most recent seed that you can get. So we've talked about how we fix the soil physically and chemically, put out the seed, and how we select the seed. So now we need to protect the seed. So let's talk about different types of ground cover. Our standards would be straw mulch or erosion control blankets. And in some areas, particularly on steep areas or where there's water flowing, we might use a permanent soil reinforcement mat. There's other materials available like hydraulically applied mulch, or what we normally call hydromulch. Compost sometimes is used in small areas. And then we can add polyacrylamide to the mix to reduce erosion. And we'll talk about each of these in detail. So the straw needs to be put out at 1 to 2 tons per acre, sometimes more. But the key is you need to get 85 to 95% coverage in order to protect the seed and get a good stand established. This is for slopes that are 2 to 1 or flatter. So steeper slopes need to have blankets or hydromulch. It needs to be uniformly spread, of course. If it's too thick in one area, it may kill the grass. And of course, if it's too thin, it doesn't protect the seed. So make sure there's enough to cover the area. Straw actually has a lot of good properties if it's put out properly. It shades, it reduces erosion, holds the moisture for the seeds, allows circulation so we don't have diseases, and sunlight can penetrate in those little crevices in between the straws. However, straw has a tendency to blow off where you've applied it if you don't apply a tackifier. So often we will put out an asphalt material. We're transitioning to hydromulches at a low rate, and we'll get to hydromulches in just a minute, but those are very effective at holding the straw. There's other materials as well, but the key is to bind it together and hold it in place until the grass can get established. Did we put enough straw out on this particular site? Well, if you look sideways, it might look like it. But when you get up close and you look down, you can see that there's a lot of soil showing, and that's a big problem. All the seed that's in those areas where it's bare is probably going to die. It's not going to be able to survive dry periods in between rainfall events. So this is probably less than half the amount of straw that you need to have to protect the seed. There are many different kinds of erosion control products. Typically for DOT projects, they're made out of an Excelsior product. That's a curled wood fiber. You see the blankets in these pictures are Excelsior blankets. They can be on 2 to 1 slopes or steeper, or where we've had trouble establishing grass, which you can see on the highway on the right. These need to be stapled in and trenched in order to be effective. So in the top left, you see here a pattern of staples holding the blankets together. So they need to be overlapping on top of each other, at least 4 to 6 inches, and then staples put through both blankets. In addition, you can put staple check dams in. That slows the water down as it moves down the slope. There are patterns you see here that are given for different types of blankets or different slopes, but the main point of all stapling is to hold the blanket against the soil. That is what we're trying to do, keep it flat against the soil. So you need to put enough staples into the blanket that holds it flat against the soil. Very important. No matter what your pattern is, as long as you've got it, the blanket held against the soil, then you're okay. If it's not up against the soil, then you can get erosion underneath the blanket, and you wouldn't be able to see it until it got to be really bad. Now, very critical, on the lower left-hand side, you see we've got a trench diagram. So we need to make sure the top part of that blanket is trenched in so that water can't get underneath it. And the next slide, we'll talk about how that's done. Well, actually, we're not. Let me go back. This trench here, you see, we've got the blanket installed, a staple in each side of the blanket, and then we roll it down across the trench so that we make sure that that trench is protected as well. If you're in a ditch, then you may be needing to do additional measures. For instance, as the blanket ends, you need to make sure the next blanket is underneath the uphill blanket so that water can't get underneath it. Again, stapling through both blankets to hold them in place. Very critical to have overlap between the blankets going down the slope so that water can't get underneath that either. So very critical that we get this installed correctly where there's flowing water. There are many, many different kinds of erosion control blankets. On the left, you see many with a netting of some kind or another. Sometimes it's plastic, sometimes it's a fiber material. On the right, these are made out of a coconut or coir material. They do not have a netting. They actually are just woven together. And these are used mostly around streams. As I said, the coconut fiber mattings are used around streams. That's primarily because they last a long time. They're made out of the same material that doormats are made out of sometimes. And again, it's because they are very rot resistant. They will eventually degrade, but it may take 3 years, 5 years before they are disappearing. And by then, hopefully there's vegetation all coming up through those blankets. Excelsior, as I mentioned, is the most common we see on DOT projects. There are straw blankets. They're the least expensive that are also out there. One thing critical is that we don't use any type of blanket that has plastic netting anywhere near where there might be wildlife. And that's generally where we talked about earlier, within 50 feet of any water bodies. So these are some examples of snakes that have been trapped by that plastic netting that holds the material together in the blanket. And this is very common. So we want to make sure that where the snakes might be, we don't want to have plastic netting. Instead, we would use that coconut fiber material, which does not trap wildlife. Sometimes birds can get trapped in that plastic netting as well. If we're going to have a blanket instead of, say, a lining with rock, then we will use a permanent soil reinforcement matting, sometimes called a turf reinforced matting, because these will be seeded and grass will grow up through the netting. And as a result, between the two of them, they will form a strong enough bond to resist any kind of erosion in these ditches. There's many different kinds of them, but again, these are products that are much more expensive than the other types we've talked about, but compared to rock and a geotextile lining, which you might normally have, they may be actually a little bit less expensive. And then we also have the hydromulch or hydraulically applied mulch. So these are materials that are mixed up in a tank of water and sprayed out sort of like paper mache. And the idea is that as you will be able to spray on a blanket and prevent erosion by having this spray on blanket on these slopes. So note that we do have the low rate, the 1,000 to 1,500 pounds per acre that you would apply on top of straw. So lower right-hand side, that's what this is. Or you can go with a higher rate and apply it to different slopes, depending on the steepness of the slope, what material you might use. Wood fibers can be used on less steep slope. And then they have these fiber reinforced materials. There's many different kinds of those. They're much more expensive, but they can be applied to steeper slopes at a higher rate. So what's really important is it's applied correctly. So hydromulch needs to be applied both from the top and the bottom. This is a case where, going back, for example, they're trying to apply it all from the top. And this is what happens when you do that. You look down the slope, you can see, well, it's still not a very good coverage, but when you look upslope, you can see the downhill side of all of those little trenches that we had with the tracking are not covered. So we've got essentially a 50% coverage when we apply the material only from the uphill side or the downhill side. So in this case, this is a truck that has a hose on it. They can reel out the hose to get down here to the bottom and shoot half the material up the slope, and they'll get the coverage they need. Lastly, there's another ground cover that's occasionally used, that's compost. Sometimes the seed is actually mixed with compost and applied. You can see in this case, it's actually being applied on top of a permanent blanket. So this is not done normally because it's very expensive relative to straw or other materials. However, it is very effective and tends to grow grass quite well. We also have another material, a chemical called polyacrylamide, which we introduced earlier in talking about turbidity control. Well, polyacrylamide also can be applied along with straw or other materials that are used for erosion control to further reduce erosion. So it actually reduces erosion beyond the control that you would get with whatever else you're applying. So it could be hydromulch, it could be straw, it could be a blanket. So we generally will put out about 20 to 30 pounds of that, and we've seen pretty amazing results in reducing erosion and getting higher quality water off those slopes. I'm going to do a demonstration.
So we have just rained on these boxes of soil with different covers on them. We've been raining at a rate of about 2 to 3 inches per hour. So pretty heavy rain. And we've got different types of covers you can see. We've got straw, we've got a long-term blanket made up of coconut fiber and plastic netting, and we've got Excelsior with netting. So those are the 3 different types of cover we have. In addition, we have applied polyacrylamide powder to these last 2 boxes, one with straw and one with Excelsior, to see what effect that might have on turbidity and erosion in these boxes. So our first box is bare soil, so you might call that a control, but it shows you just how bad erosion can be when you don't cover up the soil. So we've collected the runoff, and here you can see how muddy it is. If you reach in there, you can actually feel some soil. So we've had a lot of erosion right here. Okay, and then our straw doesn't look a lot better. I don't have any sediment in here, so the heavy soil stayed in the box. It still looks a little turbid, but it's an improvement. And then we've got our long-term blanket, and you can see actually the water quality is even a little bit better, but still turbid. But we've probably reduced erosion in these boxes by 90% or more. Same over here with the Excelsior blanket. We have kind of turbid water, but we don't have any sediment. So we haven't lost the heavy sediment, just turbid clay material that is washed off these boxes. Now, over here, we've had the same ground covers as a couple of these boxes, but we added the polyacrylamide powder. So let's see what we get there. You can see quite a bit of difference. So this is straw with polyacrylamide, and this is the straw without the polyacrylamide. So you can see the impact. We've reduced erosion and turbidity tremendously just by adding about 20 or 30 pounds of polyacrylamide per acre on top of our straw. Similarly, we can get results just like that with any product. So you need to have some kind of a ground cover, doesn't matter what it is, and then you add the polyacrylamide. You can't just have the polyacrylamide, otherwise you won't get these kind of results. So again, this is Excelsior with polyacrylamide, and this is Excelsior with no polyacrylamide. So I think you can see adding a little bit of polyacrylamide makes a big difference in what kind of water is going to come off your slopes. What about cost? Well, we're looking at about 20 pounds, let's say. That's going to cost you somewhere in the order of $150 to $200 plus whatever application cost it takes. And usually you can mix it in with something else like fertilizer, lime, something else you're applying out there, the seed, so that it's not an additional cost. So on top of the cost of straw, which might be $2,000 per acre with seed, fertilizer, lime, etc., or the blankets, which would be somewhat more, adding $100 to $200 is not a lot, and you get tremendous benefits.
So there are times when we're going to do temporary seeding. So that's when we've done our grading. We might be coming back to do some more, but it's going to be left bare for more than 7 to 14 days. So we need to cover that up with something, whether it's just straw or depending on how long it's going to be, you may need to put seed out if it's going to be, you know, a matter of months or something like that. We also, when we're done grading a part of a slope, we can do stage seeding. So here you can see on the left side, we've got a highway. The slopes going up to the highway bed are done. They're not going to be graded anymore. So we went ahead and got grass established on those. And then on the right-hand side, you can see they're moving down the slope, and they've finished the grading needed for the upper part of the slope. So they went ahead and sprayed some seed and hydro mulch out on the slope as they continued down and finished up the bottom of the slope. And this is a really good practice. And once you're done with an area, you might as well get vegetation established on it. Here's a good example of what happens when you track across the slope. So it's stage seeding. They were done with the top of the slope and they established grass up there. But then as you see the water came out of the grassed area, it started to follow those tracks. And that's why we don't track across the slope. And again, when we're done with slopes, we're going to have permanent seeding on there. And we want to get that out as soon as possible. We talk about 7 to 14 days, but the next day is even better. So we want to make sure all these areas are stabilized and we don't have a lot of erosion occurring. All right, well, I hope that answers any questions you had about how to get vegetation established on NCDOT projects.